I guess this means that we're at example. Actually, this is so we're starting section 5.4 now. Okay, and we've got a point, -5, -12. And we'll just call it P, lies on the terminal side of theta. So this point lies on the terminal side of our angle theta. So I'm going to graph this point. Both x and y are negative, so we're in the third quadrant, right? So we go 1, 2, 3, 4, 5. That's -5 for x. And then we're going to go down 12 units. Okay, so if we plot that point, we're right here. Okay. And so I can form a triangle. So here's the terminal side. Here's the initial side of our angle. And so this is our angle here, theta. Theta, or the point lies on the terminal side of theta. So here's the terminal side, there's our point, okay? Now, there's a reference angle that goes with that. And so we have a triangle here. And we want to calculate the trig functions for this triangle. So the trig functions, if we look at that, sine of theta, well, think about it. The sine of theta is going to be r or y divided by r. So r is the distance from here to here. Okay, that's our R. And notice that R is not equal to 1, so we have to include it in our definition for our sine function. So if R is equal to x squared plus y squared, then what that amounts to is we have -5 squared, that's my x, plus -12 squared, that's my y, and that's the square root of 25 plus 144, which is the square root of 169, which is 13, okay? So this distance is 13. And so sine of theta is going to be, now, opposite, so here's the angle, the reference angle, and we're talking about the opposite, which is this distance here, and we're going to use the same sign as y. So we have -12 and r is 13, right? Y is -12. I should probably label my point here so I'm not confusing. Okay, here's the y value is -12. The r value is 13. And then cosine of theta is then x over r, which is -5 over 13. Tangent of theta is y over x, which is -12 over -5, which is 12/5. And then the reciprocals, cosecant of theta is the reciprocal of this, so -13/12. Secant of theta is the reciprocal of this, which is -13/5. And finally, cotangent of theta is the reciprocal of this one here. This is just 5/12. So that is how you calculate the trig functions for this particular triangle. Now remember, triangles are similar. So if I want to, I can go in after the fact and just say, well, instead of working with this triangle, let's just go ahead and divide by 13. If I divide this side by 13, my r is going to be 1. But if I divide this by 13, then I have to divide this length by 13. And I have to divide this length also by 13. So as long as you divide each side of your triangle by the same value, you're going to get the same values for all of your trig functions. They're going to be the same, okay? So what happens is, let me just show you how that works out. So sine of theta then becomes y over r. Well, y now is negative 12/13, and r is just 1, right? Because I changed all these values. But notice the sign is the same. So this particular example is really great to show you that it doesn't matter the size of your triangle. All that matters is that your angles are the same. And if I divide each side by 13, this alpha isn't going to change. The angle and the theta is going to be the same, okay? So that's why we want to work with the unit circle. So cosine of theta, and I don't have to do this for every one, is x over r. X now is negative 5/13, r is 1, and so I get the same answer as I did earlier, okay? And you can do the same thing for all of these trig functions. The trig functions stay the same. So from now on, we're just going to work with triangles that have length 1 for the radius. And they come, or for the hypotenuse, and those come from the circle. It's like a central angle. So we're going to be looking at the coordinate plane x, y, and we're just going to be looking at the unit circle with radius equal to 1. And all our trig functions are going to come from the unit circle from now on, because it doesn't really matter. So when you're doing your homework and your question is, which is a really good question, how do I know when to use r equal to 1 and when to calculate r like I do here? The answer simply means it will say in the problem that the point lies on the unit circle. If it says that the point lies on the unit circle, automatically you know r equals 1, okay? If it doesn't say, if it just gives you a point and it says it lies on the terminal side of theta, then you have to calculate r and use it in your trig function formulas here, okay? So that's how you know. So we're going to turn our attention now to the unit circle, and we're going to get a lot of practice with this. Here we have the unit circle. You can download or print this out off the internet, and the website that you want to go to is embeddedmath.com. And if you just Google it, let me just share my screen here to show you how we do that. So you go to your search bar and you can just type in embedded math. You don't even have to do the .com. You can go embedded math unit circle. And if you type in blank, it will give you a blank one. And if you type in filled in, it'll give you the filled in one with all the correct values. So here's a blank unit circle. And this is where I got this printout from, okay? So you can print it out yourself. And we're going to go ahead and fill this all in together now. But like I said, if you go back here, you can get here's the blank one. You can also get the filled in one. Right here, all those values are filled in. So let's go ahead and go through this process. I'll show you how to analyze these angles. So basically, we've taken a circle, the unit circle. This distance from the origin to the edge of the circle is 1. So we don't have to use r in any of our trig functions, okay? We're just going to use x and y. And since r equals 1, we don't have to do the calculation, okay? So let's first talk about where these angles come from, all these angles here. So I'm going to start with a diagram, and we're just going to talk about the basic angles, and then we'll fill these in as we go. But first, let me go back to the dot cam. Okay, so there are quarter angles. We did that. We talked about that earlier. Let me just go over that again. So anything, the quarter angles are pi over 4, 2 pi over 4, which is, if I reduce this fraction, it becomes pi divided by 2, 3 pi over 4, okay? 4 pi over 4 is just pi, right? The 4's cancel. Then we have 5 pi over 4, 6 pi over 4. That simplifies to 3 pi over 2. And then we have 7 pi over 4 and 8 pi over 4, which of course is 8 divided by 4 is 2 pi. Okay, so these are when you take your half circle and divide it into fourths, or you're taking your whole circle and dividing it into 8 parts. Okay, the reason why I do the half circle is because, remember, the half circle is your pi. Okay, so I'm dividing it into fourths. Pi, pi, pi. Okay, so this becomes pi over 4. The next one is pi over 2. That's this one here. Then 3 pi over 4. Then pi. I'm doing this on this sheet of paper because there's so many lines on this sheet that I don't want to look at them all at once, okay? I'm just now looking at these quarter angles, okay? That's what I'm doing right now. So that's why I've drawn it like this, just so you can focus on just those angles. So this becomes, this is supposed to be matching. So this is 4 pi over 4, which is pi. This is 5 pi over 4. This is the 6 pi over 4, or 3 pi over 2 when you simplify. Here we have 7 pi over 4, and then coming back to 2 pi. So you start at 0 and you end at 2 pi, okay? Now, we want to calculate the trig functions for those different angles, okay? And just so that we can work in degrees as well, let's go ahead and fill in the degrees. So pi over 4 is 180 divided by 4, which is 45 degrees. Pi over 2 is 180 divided by 2, which is 90 degrees. Then you've got 3 pi over 4, which is 3 times 45, which is 135 degrees. And then we have, of course, pi is 180 degrees. 5 pi over 4 is 5 times 45, and that is going to be 225. And this is going to be 270 degrees. This is 7 times 45, which is going to be 315 degrees. And then you come full circle, 360 degrees. Okay? So going back to our chart, if you want to kind of do this on your own for practice, you can. But going back to my chart, I'm going to take all these things and fill them in here. So 0 degrees, 45 degrees. This one is 90 degrees, 135. This is 180. This is 225, 270, 315, and of course 360. Now, sorry about that. It's kind of hard to fit the whole thing in. Maybe I should go a little higher. There we go. Okay, that's better. Okay, I'll let you catch up with me. I feel like I'm going too fast, so I better slow down here. Let me see what time it is. It's 4:19, so we got maybe 25 minutes left. Okay. We're not going to finish this probably today, but we'll work with it. Okay. So now let's go ahead and fill in the radians. So 0 degrees is 0 radians. 45 degrees is pi over 4. 90 degrees is pi over 2. 135 is 3 pi over 4. 180 is pi. And 225 is 5 pi over 4. And then here we've got 3 pi over 2, 7 pi over 4, and then of course back up to 2 pi. Okay? Now, the next, we want to calculate all these values. See that point there? We want to know what x and y are, because if we know that, then for this angle, we can calculate our trig function, right? Because the trig functions for a circle with radius 1 are all going to be in terms of x and y. So if you know x and you know y, you can calculate your trig function, okay? So we need to decide what are all these values. So I'm going to show you how that works. We're going to go back to this page because I don't want it to be so cluttered. And we're going to focus on 45 degrees. And I kind of did this earlier. If you drop at this point, there's the point of interest. That's the x, y that we want to find. If you drop a line down, this angle here is your 45 degrees, right? This angle is 90. And so that means the only choice that's left is 45 degrees there. Well, that's an isosceles triangle. And remember, our circle has radius 1, right? We drew it that way on purpose. We said we were only going to work with the unit circle now, right? So this distance for all of these r values is going to be 1. That's the hypotenuse. And then we have this side, this side. This is your height. This distance is your height. That's your y value. And this distance here is your x value for that point. Okay? So remember, we did this earlier. This is square root of 2 over 2. This is square root of 2 over 2. Okay? So that means this point has an x value of square root of 2 over 2 and a y value of square root of 2 over 2. So we found the x and y values for that point. Okay? So going back to our chart, we can fill in right here at this 45-degree angle. That's this line right here. We can fill in square root of 2 over 2 and square root of 2 over 2. Okay? Now, it turns out that if we draw these triangles for the same type of angle, so these are quarter angles, right? So this distance of this right here, if I copy it and slide it over here to this angle, I'm going to get the same height, okay? And it's above the y-axis, so that y value is going to be positive. So I can just transfer this height over here, so the y value is square root of 2 over 2. And I can flip this distance from this origin to here is this x value, that's square root of 2 over 2. I can just flip it over, so it's going to be the x value there, which is square root of 2 over 2. But because this is to the left of the y-axis, it's going to be negative, right? The x value is going to be negative. Okay. Now we do the same thing for these points right here. This triangle, if I draw these triangles in here like this, they're all going to be the same triangle, just flipped. You know, this one flipped over here, this one flipped over here. But the distance for x and y is going to be the same. The only difference is going to be the sign. So here we're going to have square root of 2 over 2, square root of 2 over 2. But both of these are in the third quadrant. So both x and y are negative in the third quadrant. Here we have square root of 2 over 2, square root of 2 over 2. Now the x is positive, the y is negative because we're in the fourth quadrant. So that's how you find these points. You just make these triangles and note that this is 45 degrees, this angle. So it's an isosceles triangle with hypotenuse 1. So it's that same triangle that I drew earlier, this one right here. And I had already calculated the length of those sides to be square root of 2 over 2. Okay? So that's how I got these numbers. These triangles are the same ones as the one that I did here. Okay? So we're starting to fill in most of this unit circle, but we did it now for the quarter angles. Now I want to focus on these other angles. These are the 30 and 60 degree angles. So let's go back to my other, so here are my quarter angles. Now I'm going to do the other circle, or the other angles for the circle. This is a unit circle, right? And it's kind of lopsided, but just bear with me. It's supposed to be the unit circle. This distance from here to here is 1, all the way around the circle. Okay? And we've already done the quarter angles up here. Now we're going to do thirds. Okay? We're going to take this whole circle and divide it into 12ths. And so really the half circle is going to be in 6ths. 6th, or like that. They're supposed to be equal parts. I know they don't really look like it, but I'm trying my best to draw this. So this circle has been divided up into 12 equal parts, okay? So half a circle is pi, and that 1, 2, 3, 4, 5, 6 pieces in a half circle. So this is going to be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and then of course 6 pi over 6, which is just pi. This simplifies to pi over 2. This simplifies to pi over 3. Here this is 2 pi over 3. This can't be simplified, okay? So there we have. And if we keep going, this becomes 7 pi over 6, 8 pi over 6, which is 3 pi over 4. And that's not right. 4 pi over 3, that's what I meant to write. There we go. 8 6 reduces to 4/3. And then we have 9 pi over 12, which is 3 pi over 2, 10 pi over 12, which is equal to 5 pi over 6. Then we have 11 pi over 12. I meant this to be, this is supposed to be 6 here, sorry. So that becomes 5 pi over 3. There we go. 11 pi over 6. I don't know why I'm doing 12. I think I was thinking because there are 12 pieces. But remember, we're doing half circles. Half circle is pi, so each piece is pi over 6. So we have pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8, 9 pi over 6, 10 pi over 6, 11 pi over 6, and back to 2 pi, which is 12 pi over 6. Okay. So then if you want to do it in degrees, this becomes multiples of 30, right? Each pi over 6 is 30 degrees. So we have 30, 60, 90, 120, 150, 180. And then we've got 210, 240, 270, 300, 330, 360. Okay? So and this becomes 120. This is 150. Add 30, you get 180. Add 30, you get 210. Add another 30, you get 240. Add 30, you get 270. Then 300, then 330, and then 360. Okay? So going back to our chart, okay, we can go ahead and fill in all that information. Okay, so we've already done the quarter ones. Now we're going to do the sixths. So this becomes 30 degrees or pi over 6. Then we have 45 degrees or pi over 4. 60 degrees or pi over 3. We already filled that in. Then we have 120 degrees, which is, let me think for a second, 4 pi over 6, which is 2 pi over 3. Then we have, right here, we're going to have 150, which is going to be 5 pi over 6. 180 is pi. Here we're going to have 100 or 210, which is going to be 7 pi over 6. Here we're going to have, that's supposed to be a 1, by the way. It looks like a 4, but this is the 240 here. And then this is going to be, here's 7 pi over 6, so this is going to be 8 pi over 6, which is 4 pi over 3. Then, of course, we have the 3 pi over 2. And then this is the 300, which then is, let me think, 10 pi over 6, which is 5 pi over 3. And finally, the 330 degrees, which is the 11 pi over 3. Or 6. Sorry. Okay. So a lot of angles that we're filling in, okay? But we're getting close to the end. Now we just have to draw our little triangles. And this is so cluttered, okay? I'm going to go back to this one. And if I drop down this line here, this is a 90 degrees. This is my 30, and this is my 60. Remember the special triangle that I talked about right here. The opposite of 30 is 1/2. The opposite of 60 is square root of 3 over 2. So here's my 30. The opposite, this height is 1/2. And this distance here is square root of 3 over 2. Well, that enables me to fill in. This is the y value. 1/2 is the y value. Square root of 3 over 2 is the x value for this point right there. Okay, so I can write that in as square root of 3 over 2, 1/2, like that. And then this triangle, I can flip this thing over here. And so this would be my 60 here. This is my 90, and this is my 30. That's the reference angle or reference, or it's a triangle that I'm using. And since I flipped it over, the x value is going to become negative over here. So it becomes negative square root of 3 over 2 and then 1/2. Okay, And then I flip this down here. It's going to, this point is going to be negative square root of 3 over 2, but now the y value is going to be negative because it's below the x-axis. It's 1/2, and it becomes negative 1/2. And then if I flip it back over here, this point, the x value is positive, so it's going to be square root of 3 over 2, and the y value is still negative, okay? So that's how you fill in those points. So when we go back to our unit circle, here, we've got square root of 3 over 2 and 1/2. We have negative square root of 3 over 2, 1/2. And then down here is going to be negative square root of 3 over 2, negative 1/2. And then over here, it's going to be square root of 3 over 2, negative 1/2. Okay? See how that works? Now, when we do these right here, we are going to use a triangle that we draw like this. It's still a 30, 60, 90. The difference is this angle now is the 60, this is the 90, and this angle up here is the 30. So your distances are going to change. This is 1/2, so now my x value on this side is negative 1/2. The height is the square root of 3 over 2. That's the y value. Over here, they're both positive, so we have 1/2 for x, square root of 3 over 2 for y. Down here, this point gets flipped down here, so now x is still negative 1/2 and y is negative square root of 3 over 2. And then we come and take this point, flip it down here, so we have 1/2 negative square root of 3 over 2. So we're using the same lengths, but the sign's changing as you move around to the different quadrants. Now, all that's left for this unit circle to be complete are the quadrantal angles. And those are easy because here, this point is just the x value is 1 and the y value is 0 because I'm on the x-axis and this distance from the origin to the edge of the circle is 1. That's your x. And over here is negative 1, 0. Up here, y is 1, x is 0. Down here, y is negative 1 and x is 0. So there we have it. That's our unit circle. And if you go back to your, you can print it out if you want to have it in your notes. Here's our unit circle. Okay. Now you will have this as a reference for your first test, but when you take the exam, you won't have it to look at. So it's okay to use it for the test, which is online, but you want to have this memorized by the time you get to the exam, the midterm exam. Right here, let me show you how to memorize this. Okay, first off, notice the denominators are all 2's. Every denominator has a 2 in it. So you write down all the 2's in the denominator. Then you go 1, 2, 3 as you work your way down the x's, and then you go 1, 2, 3 as you work your way up for the y's, and then you put the square root over all the numbers that are not equal to 1, because the square root of 1, of course, is just 1. So you don't need a square root for that, but then all the other numerators have square roots. And then the other ones are just, so here the x values are all negative, the y values are positive. Here the x values are negative and the y values are negative. And here x's are positive, y's are negative. So that's how you memorize, or how I memorize all those points. And the angles, you're just kind of, you learn from dividing up your half circle. Let me go back to my document camera. And you either are dividing your half circle into fourths, or you're dividing your half circle into sixths. And then of course you have to reduce the fractions, okay?